architecture also that was mostly we use. Okay, so before this, let me do one thing. Okay, because right now I'm running with some of my applications or the pod or the load. Okay, and that to run by application keyword. There's a CRD from Argo CD. So what I can do, I can tell my Argo CD with Kubernetes that this is the application you have. Can you please delete? Okay, so this application has been deleted. Okay, and the application what you delete from the command line, same thing you can see from here also. This application deleted and application deleted. So whatever guys Argo CD have done for you, it should be delete actually, but it is not deleted because there's a way actually I did kind of in a brutal way. It's not gracefully. Okay, so they does not clean it because that does not allow. Otherwise, there's a way from here to go and delete your application. So that's okay. But Argo CD is not controlling. That's the one point. So we left the control of Argo CD from here. So let me delete in our way. So let me delete. I just want to clean my environment. That's all what I am doing. So what are running in my default namespace? I will have to clean all because my plan is to create some and launch some new application at this point in time. Okay. So let me give this command. So now we are going to launch you guys very interesting architecture or the application I can say. So for this, what I'm doing, I have this application already hosted in my GitHub. Okay, so the application what I am looking for, what I am looking for is what was the name? It is it is a book. It's I believe this one. Okay, so this is the kind of micro service based architecture. Okay, so very quickly let me brief you what is this all about. So someone has created this application. I have actually get from somewhere from the internet. Okay, but what this application is doing, let me explain to you. It's very interesting, and on the top of this we can understand a lot of Kubernetes and other component or the tool concepts. Okay, so what this application is doing, so we have one application created by some multiple developers. Okay, so one developer has created application, this product page using a Python as a language. Okay, so any client from outside world, if they hit to this application, they can see some web page where my product has been listed. Okay, has been listed. Okay, but this language, this app is created in Python as a language, but this page is rendering a lot of data from backend. So whatever you see in this front end is a kind of front end or the UI. So whatever data you will see in this front end is actually coming from some from backend. For example, they are fetching some information from some backend services. So some other team I have created one more app that will show the product. Here the product is books, and this product this app they created in Ruby as a language, and this app is running in some different server. In my case, so this product page is getting the information from this backend app or service only for the product details. Okay, and every product guys we are seeing the review, and those review my Python program is hitting to this app that is written in Java in this case by chance. So here they are getting the review, Initially, my Java developer has created an app with version 1. That point in time, they're only showing you review without star rating. So they do some changes in the version. They come with a new version called V2 and they deploy this version. Now my product page, when they hit to this app, now they will see the review with rating. And those rating guys, again, my Java app does not store by themselves. So they again behind the scene head to some backend services. They are getting maybe some from database or maybe have some static information here. And this app is written in the Node, the JavaScript. Okay, but that point in time, we are providing the rating in some black color. We don't like this, so we update the code in Java language and launch version 3. Version 3. And then when any client hit to this app product page is heading to version 3, and version 3 app written Java is heading to Node.js. From there, pulling the rating, and this app is converting rating to red color and provide to the front end. So technically, if you notice, there's individual programs are running. Now it is your choice. Those programs you can run as a pod. So there's a multiple pods we are going to run. One pod for rating, one pod for detail, one pod for review, one pod for front end, or all the pod running with multiple different apps, and they work together, become a one single app. But every pod here is running with their small particular capabilities are known as microservices, and all the microservices work together, become a one single app. Okay, this is one point. But here, because of microservices, now every component has I would like to use. And here I use multiple languages. So I can say this setup is polyglot. So I'm using polyglot kind of microservice architecture. Okay, and that's what we have. Okay. And now because every app is written in some language, is a rating app. And if you run this app, you have to create an image. And from the image, you can launch a container or the pod. Okay, so right now this entire app code I have with me in my GitHub. Okay, so if you go to this URL and if you go to source folder, so we have code for product page, rating, review, detail. And if I go for the product page here, so this product page is a code written in Python by chance. So this is a pure Python code. Okay, so someone has created the Python code. I think this code written in Flask framework. Okay, and so this is a one app. Okay, so what we can do, if you want to run this app directly, you can run directly. But if you want to run in the container, you can first create the image. And for creating the image, you need a Docker file. So we have a Docker file here that I told you in my last class. So we have a Docker file. We are using some base image of Python, installing some Python Flask libraries. Okay, and then running some CMD or maybe some entry point to start the app on port number 9080. Okay, so this is just a Docker file. Most of the part of the Docker file we have already discussed. Now what we can do, you can download this code, build the image by yourself, or you can run the Jenkins. Jenkins will go and download this code and build the image for you and push the image to the Docker Hub. This part I already done in my case, because this part we discussed already in my last class. So if I go to my Docker Hub somewhere, okay, so these images I already built and store into my Docker Hub. So if you see a repository, okay, so these images I already built, and I have a code for review app also. Okay, version 1, version 2, version 3, and rating app also in detail. So all the images I built from the code that is there in my GitHub. Okay. Now, if you want to run this code, it is your choice because we have an image you can run in the Kubernetes if you want. And for running the Kubernetes, you need a YAML file. So I also have one YAML file here that I already explained to you. Book.yml file I have here with me. Okay. So here I have a YAML file. In this YAML file, I am creating one service. Okay, because technically everyone is an individual pod from the individual images running with individual program. Okay, so it is always good practice. Okay, every pod you should run behind the load balancer. So there's a rating pod from the rating image. So you have to provide a separate load balancer to this guy. Why? A lot of reasons. Okay, load balancer will help you to expose if you want to expose this connectivity, or one of the reason, maybe right now I might not have so much load, but in the future if there's a load, I can very easily scale these guys. Okay, so we don't have to change the IP address to the one who is currently writing app. So they keep on using same load balancer, same IP address, but behind the scene we can scale in, scale out. This horizontal scaling we can do very, very easily. So that is a reason whenever you launch any code from some of the image, let's say detail image. Okay, so this pod we are going to launch, and obviously we launch by the help of deployment. Why? We discussed this for proper strategy of new version. But we should create, not compulsory, but we should create a separate service of the Kubernetes for detail app also. Okay, so that's what we have done here. So we created a separate service for the detail app. And for detail app, I am deploying the detail app from the image that I upload in my Docker. So this code is launching a deployment that is called pod. And this pod, we tag with some level that help us my load balancer to connect. That you have to connect with the one who have this tag. Let's go app.detail. Okay, so technically this line will do two things: deployment, port launch, and plus add the services. Okay, and same file, guys, I have write the code for everything. We have run one more service for rating app, and plus rating also we are deploying from the image in the one copy only from the rating image. Okay, but in this example, what we have done, okay, for review, I'm launching all three versions of the review. Because initially we might come with the version 1. It was working good and fine. But we thought to launch one more version of review, version 2, with the rating come from some backend. Okay. So what I am doing, rather than I delete this version 1, I am running both the version together behind the same load balancer, this service. That means, because service is the one that will work as a round robin way in the Kubernetes. So any traffic come from somewhere, in this case, they're coming from the product page. Okay, so they will do load balancing. So sometimes they show you this page, sometimes they show you this page. And why I'm keeping both the version, maybe I just don't want to delete or stop my old version. I want to check my version or new version for some time. Then maybe in the future we'll remove. But at the same time, I have also come up with one more version called V3 of my review. And this also I am running behind the scene. Technically, I would like to run all three. Running all the three in service. So service always send the traffic equally distribution of round robin. That's what Kubernetes support. Kubernetes does not support, guys. I would like to again repeat, Kubernetes does not support unequal distribution, or this called weighted routing or distribution. They only support equal distribution. That's called round robin way. That is one of the challenge in the Kubernetes. This challenge will solve in some time with the help of Istio service mesh. So my plan is right now to send the traffic to all the version equally. But after we test V2, then slowly, let's say everyone is getting almost 33% of the traffic, almost equal, 33-34%. Okay. And after we test V2 or V3 wasn't working good for review, so what we will do, slowly we decrease the traffic to this guy to let's say 10%, and we increase somewhere here. Then slowly we decrease this traffic to 0% always. Then we send the primitive here, or maybe slowly I will decrease this guy to 10% and get 90% traffic here. So all the traffic routing we can control. That's what I want to do. This is one of the example of canary release, that slowly we start sending a traffic to some of the version. And all the version I keep on running. Okay, but so if you go for deployment strategy, the strategy what I was talking about till now is rolling update. So in the rolling update, if V1 is there, if you launch V2, V1 will remove completely. Rolling update, only one version one work at one point in time. Okay, but in the canary release strategy, okay, what we can do, we can run multiple versions together of the same app. Okay, so that can be done in Kubernetes, but Kubernetes will send the traffic always equally because it run behind the scene all the guys the same load balancer. But in the canary release, mostly the requirement would be the old version I want to send more traffic, 90%. New version I want to send less traffic because I have no guarantee how new version gonna work. After we do some tests from the client something, then slowly we decrease this number and increase this traffic. That's called weighted routing in the world of load balancer. That's what we normally do in the canary release. But this is not supported by Kubernetes. We can do some trick in the Kubernetes, is a different point, but it's not. Canary release, we can use a product called Istio service mesh that I will use in some time. Okay, so this is an entire setup, guys, and this YAML file is almost we have discussed. So I'm also running one more service for the review. But if you see, I'm using only one service. Okay, and this service is selecting a pod with app review. And the deployment, I'm launching revision 1 with the same name app review. And I'm launching one more deployment with revision 2 with same level. Okay, and one more deployment I'm launching version 3 with the same level. So a level, guys, in the Kubernetes world, the level is very important concept. This is the one that will connect the multiple component together. So my load balancer does not recognize my backend pod with the name of IP address and the name. So everything we tag, okay, and those tag is called labels. So when you launch any pod, we give them the level, like a tag, like app review. And then I'll tell my service that I don't need to tell you IP address. IPs keep on changing. My pod name is also keep on changing. So the way you connect to my backend, okay, just go and select the pod who have this tag. This is how, guys, in the Kubernetes world, even though this is a big topic, we take almost one class to make you understand this topic normally in my training. But I think this is the quick way to explain. Okay, so this is again the entire code I write in this file. So one thing I'm doing, let me click on row and let me take this URL from here and let me apply this code in my Kubernetes cluster. Okay, right now I've just applied directly. You can, mostly good practice is you can go via Argo CD, but to make the thing very quick right now, that, and I think you understand the Argo city. So what I'm doing, again, let me do one more quick thing here. Let me change my default namespace to be default, so I don't have to write again and again default. So I'm changing my current namespace in my client side to be default. So all the command will run with respect to default. This I'm doing. It's not compulsory, but I'm just doing to quickly make the things faster. So this is a project, guys, I am implementing right now. In this project, we are going to add a lot of things. So first thing is I'll take this code. Okay. This is pure Kubernetes. So I'll say Kubernetes apply or the create command. And I paste, and you can see the entire setup will be launched. Technically, this entire setup has been launched. And now if you notice, I have 5-6 pod launch. One is a product page in Python, is my front end. One is rating, one is detail, and 3 version 1, version 2, version 3 of the review. Plus, if you look at services, so 4 services I launched for per microservice. Okay, but if you hit to this service, a review, and behind this service I'm running with 3 pod. How I know? We can check very quickly. So if I say describe service called review, you can see this service running behind the scene with 3 ports. And all the 3 ports are my review 1, review 2, and review 3. So you can say review 1. So this is a review 1 having IP 199. That's what you can see. It is connected. Okay. So my port is running fantastically fine. Now, guys, understand one thing. All the port running with the private IP, and they are connected to services to balance the load and many more things on top of this. But all the service also running in the private world because cluster IP. Okay, because that's what we want. But typically, all the internal microservices or database, I don't want to expose. So let them running with the cluster IP. But my my product page is actually I want it to be exposed to the public world so any client can connect. So I can go to product page and change the type. And anything that is running on the fly, if you want to change something, we can patch or we can edit. So this service, this called product page, I would like to edit. I will edit. And so when I hit enter, they will open the code written in the YAML. YAML. Somewhere, yeah, this they open over here. So the service, and this is a current real-time code they show to you. Okay, and here I would like to change my load balancer from the cluster IP to the load balancer type. That's what we can do. Or maybe right now we can do many more changes here. So like now, to make it a little bit quick, let me do the what we have done already. So let me do port forwarding. That makes more sense. Okay, so this command I'm going to run here. So I can say I want to do port forwarding. I'm running with a service known as product page. Okay, and running the default namespace. And my product page is running with a port number 9080. That's all. Now, anyone who connect to this IP locally, I will connect to my product page at this port number. Okay. It's 9080. I think this side we write 9080. Let me give both the sides same. So Now it is working. So now we can see this is the URL of my product page, and this is how your app look like. Look like. I can hold for a second, please. Okay, so guys, your app has been started, and the one who create this code, they have given the I can say um, the endpoint. The endpoint I think is product page. This is your app look like. So right now I'm heading to my product page, that is Python. Okay, but here in the Python they are fetching the detail of the book. This detail is actually coming from a different microservice. That's called detail, and this detail microservice running in my case in a pod behind some load balancer as we see over here. Over here. So if I shut down this guy, okay, then obviously this part will not come. Maybe there's possibility this program maybe hang up, or there maybe possibility there's some kind of error come up. Okay, so for this there's a guys concept called fault injection chaos engineering. It's a big topic altogether. Mostly we learn this topic in service mesh concepts. Okay, so we can do some kind of fault tolerance and fault injection and chaos engineering to solve this issue, but right now we don't need to go for the direction. Okay, and similarly, if you see this is a book review come up, and right now this review is coming from my review, and right now they're hitting the version 1, and version 1 is not going my backend right now at this point in time, so my rating is not coming star rating. But if I refresh one more time this page, okay, because sometimes they create the caches locally, so let me refresh. Okay, now we can see rating come up. Why? Because my product page is now hitting to version 2 of my review, and version 2 is getting to the node rating app. From there they're getting the rating and convert into the black star. Okay, and if I hit one more time, you can see red star. It means I'm going to connect to review 3. MSA is a pure load balancing round robin equal distribution because of my service. The Kubernetes service always give equal distribution running that pod running behind the scene. That is how thing is working. Thing is working. Now the challenge here is in this app there's a front end that's called Python. This is not the one who is giving you everything. This information coming from different port, this information from different port. Okay, and this information, some information maybe if I refresh, this information coming from a port, because sometimes they create caches. Let me refresh properly. Yeah, so this information is not coming from product page. Product page is getting from review. Review is getting from node rating, and then node my rating I will give to review. Review I will give to product page, and they presented here. But sometimes if you see the rating app is coming slow, that makes the entire app slow. And now why they're slow, we have no idea, because this is not the monolithic application. So we have to work on one app. There's a microservice, a lot of component port connect to each other, managed by different team, maybe having multiple language code. So we have no idea why they are slow. Okay, so what we need here, we have to understand the root cause why something is not coming properly or slowed down. That will impact the performance and the bad user experience of my customer that we never want. Okay, so we have to have a proper visibility in this code. This called observability. Okay, and for observability, Kubernetes have no proper way as such to observe the entire traffic flow. For example, if I take this diagram one more time, okay, so Kubernetes, if you ask the Kubernetes, can you tell me, can you please tell me that format? Can you please tell me that that when I am hitting to to this app from my customer perspective, or if any customer is hitting, they'll go to this guy, and this guy is connecting to some service. Here is not visible, there's some service is here, SVC, and they connect to this service, and service is sending traffic to somewhere at this point in time, maybe here. And this guy is sending the traffic to this guy, and now we are fetching the rating here. Rating here, but we can see rating is coming very slow, or not coming up. So we have no idea why. Okay, because I don't know, maybe the code running inside this code written in Java, and you guys know in Java there are multiple lines of code, multi functions you write. Which line is creating the issue? Which part of the code is creating the issue? We have no idea. Maybe some particular loop we stuck in the code that make this code slow, or maybe there's a possibility between these two port. This is a port, let's say this is a B port. We have some network connections, and both the port A is running a different worker node. They are running in different worker nodes. You have some overlay network, real network. Maybe this network has some extra traffic congestion that will, maybe they take 1 millisecond, but now they're taking 30 milliseconds, for example, for this connection to be processed. So we have no idea, because right now if I say is only thing what I can see is something is slow. Why they're slow, we have no visibility. Okay, so what we have to do, we have to go to every part of this Microsoft architecture and start collecting the information about everything. Okay, from A to B, if you are sending the packet, when you're sending the packet, or how much time is sending the packet to come back. This is called round trip time. Or are you sending the packet, are you getting the error 200, 404, 501 of HTTP error, server error, client error? We don't know. Okay, we don't know. And plus I don't know, okay, this system is running a code, and code has been hanged. One function is taking more time. My this rating may be connected to database, and the code that is connected to database, that is taking more time for connection. So anything could be possible. Not having proper good user experience. My main point is, the important thing is a good user experience, right? That was we looking for. For example, if I go to Netflix, it is not at all possible that something goes down. It's like video streaming is going, right? There's no good reason that you can say, okay, 1 millisecond or 5 millisecond delay could be, or 1 second delay could be possible, because we can't give that experience to my client who is watching the live or a series or the movies. Okay, so as operations guy or the DevOps engineer maybe, or SRE engineer maybe, it is very very important to have a detailed internal visibility that what your Kubernetes can't do for you. For this, we have to use a monitoring tool. Or what to monitor? There are a lot of things we can monitor. One of the things what we can monitor would be, okay, I want to understand the flow of the code, where they're going, which direction they're going. This is more like a tracing. So I want to trace everything. This is what you want to monitor. Or maybe you want to monitor this rating app is running, and they're running on some system where they consume some RAM and CPU. Okay, so how much RAM is free, how much CPU is free, this is called metrics. So you want to monitor the metrics. Okay, or maybe my A port is going to B port, and B port is not able to connect, maybe is not found, some error is coming up, there may be some firewalling, we don't know. So you want to monitor the errors and connection issues, so you want to monitor logs. So what do you want to monitor? And for every monitoring, we have a different tool. There's a different topics altogether, and every monitoring we have a different tools available. For example, if you're about log, so we have a lot of tool available. You can go for Splunk as a tool to do so. We can go for ELK stack. We can go for Loki, and many tools available. If you go for metrics monitoring, then we can in every pod or every node we can install some agents who collect the information about the node and store in some database somewhere. And one of the name of database called Prometheus is a time series database who can collect the metrics information about a pod, how much pod is consumed the memory, how much memory consumed by the node, how much CPU has been used, and many things we can collect and store in the Prometheus database. Okay. Or if you want to collect the tracing information, then we have many tools available. One of the tool we can use is Jeager. We can use. Okay. And then these are the tools actually who is collecting the information. But after collecting the information, we can go for every tool have their own query languages. You can type some query languages here to retrieve some information, but every time writing the query does not make sense. So we want some visual tool, visual tools, okay, who can make my information more visual graphics form. Then on the top of Prometheus, we can collect the information, and you can use Grafana to convert into very beautiful visuals. And Jagged information we can send to Kiali. The spelling might be wrong. Kiali, to convert into very beautiful visuals. Splunk and ELK has their own visual. In Splunk, they have own visual. In ELK, we have Kibana to present in the visual way. Like this. Okay. So my point is, this is a big world altogether to understand, okay, what is going on. Okay. Because mostly we launch the app once, or maybe in a day twice, new version gonna come up, and all the new version is to be done automatically by Jenkins and Argo CD, CI/CD pipeline. But after the app deployed, then that mostly the time consumption would be on monitoring part. Okay, and that is help us in troubleshooting and many other areas also. But the biggest thing here is right now all the app is running on individual pod, and that are running on the top of Kubernetes, and Kubernetes does not give you a way to collect the information and to understand where the traffic is going on, to collect the information of traffic, and without collecting those information where the packet is going on, okay, you won't able to trace. Okay, so that is the reason what we have to do. Okay, we have to take the help of some other tool. What I mean by this, okay, so what we can do, we can take the help of other tool. For example, right now my pod is running. Let's say the pod name is called review pod, and they are running as a container in a pod. Okay, and they are connecting with the one backend port called a rating port. According to this diagram, you can see review is connected to rating port. That is again the port, but inside the port we are running a container where the app is running. Okay, and typically we have a direct connectivity from port to port, obviously via through service of Kubernetes. Okay, but what we can do instead, we give a direct connectivity. In this code, we can launch one more container and one more container. And the beautiful thing about this container is this is a special program. And what we can do, we can tell my review, if you want to go to rating, you can't directly, you have to first send your request to this program. This program will take your request to this program, and they will proxy your program to rating. So this extra program, what I write here, is also one kind of program running in the same port as a container. So in this case, it means one port is running with two containers, called multi-container port. Okay, but this program is work like a proxy program or proxy container, and this program has special capability. What they do, they will record every flow of the packet. So when the review go to rating, they record it, when they go, what time they go, how much time they come back, reply, everything they record and send somewhere, send some centralized database. That's what they can do. Okay, so this is what exactly we have to do setup. So technically, in one big pod, you are running with your one of main container. It's called app container, your main app. Along with the app, you are also running one more container that will help this app to do something. And in this case, they are helping to record whatever they are doing and wherever they are going. That's what they're doing. So this way, in one pod, if you're running multiple containers, called multi-pod container, but this design is called sidecar design. There's a design pattern called sidecar multi-container pod design, because this is a one kind of helper program who help. And there's a lot of programs that are available in the market. But if you're looking for that, whatever your review container is doing with a rating container, when they're going, how much time they're doing, what kind of issues they're coming up, right? They record almost everything. Okay, store in some database, so we can use some wherever you want to troubleshoot, want to see the observability. Okay, so for this, there's one very interesting program in the market available called Envoy. This is called Envoy proxy program we can write. Of Envoy and send this, collect the data to some central database. So we have one tool that will do this entire architecture for you, and the tool is called Istio. So Istio is one big tool. Okay, one big tool who help you to do this entire setup. And technically, if you try to see this entire setup as a bigger picture, so you will see every pod in the microservices. There's a pod one, product page, a review page, a rating page, detail page. Okay, so in every pod, they are running with their own container app, main app written in Python, Java, Ruby, and Node. But along with this, we will add or inject inject. Okay, one more proxy container. In my case, is Envoy. So technically, if you see now, everyone know everyone, every particular. Uh, let me add one more here just to give you one quick diagram, look and feel. So everyone can go via the proxy. So finally, you can see every traffic is via, wherever they go, they will go via proxy. And this topology is called mesh. And obviously we will go, don't connect directly, we'll go connect via service. So it's called service mesh. So finally, you need a service mesh to see the entire visibility, because we don't know where we can connect to anywhere. We have no idea, because developer is the one who decide product page we can do review 2 or review 3 or review 3 connect to port or rating. So that's what done by developers in the code. So from the IT perspective, admin perspective, we have no idea where my packet is going, because it is been created by the developer. Okay, so that is the reason we have to connect everyone, because we don't know where is my packet is going on. Is what going on. So this is the guy's idea. So this is the reason we have to create a mesh setup. Let's go service mesh. And to set up the service mesh, we have to take the help of Istio product. Is a product we can use. Okay, so I think as you got the idea, and now because we are collecting everything, now this information, whatever is collecting by this process, is sent to database. Is just some internal database of Istio, and this information now we can use for many monitoring purposes. One of the purpose could be test you by Agar or the Kiali tool. Okay, so let me show you how we can do this setup. So for doing this setup, guys, what we have to do, we have to first install Istio tool. And to install Istio, there's a multiple way. So if you search for Istio installation, there's a multiple way. You can install the Istio. Install the Istio. Okay, so if I go to installation part, and guys, after having the Istio, we can do many concepts to be implemented. Okay, but let me go for the installation page. So one of the way to install the Istio is using istioctl command. This is one of the way we can use, and for this you can download the Istio product from here. Okay, download the Istio product from here. So this is Istio binary. You can download from this link, or you can download from this release page. Okay, so this is the page where you can download. So you just go and download the Istio product. In my case, it's for Windows. So double click and download. In my case, I already downloaded. Okay, that's what you can use. And then here, after you download, you will see they give you istioctl command. Okay, so I think in my case I have already downloaded Istio. I think the latest version is 1.24. 0.24. Okay, so you can find this after download, and in the bin folder you will find a program called istioctl. This is what we need to use. Okay, so the first step you will do for downloading the Istio, then we have to install the Istio. And again, for installing the Istio, we have multiple way. This is the one of the way we can install. The Istio will come with the multiple profiles. And what profile, again, this is not a pure Istio training, but profile will give you what capability you want. Just to have many capabilities. But demo, if you go for it, they have a lot of capabilities here. That's what I want to use. So here I can say I want to install Istio. Okay, Istio with the demo profile. Enter. So technically they are installing the Istio. Okay, I say yes with some and a lot of capability whatever Istio has given to us. So let me share these commands to you. Okay. And the command from where I download this also link, let me give to you. And I think I have this document for this Istio with me. I'll also share the document. Istio has been installed, and how I know. So when you install Istio, they will create their own personal name space. This is called Istio system. In this namespace is to put there a lot of things, whatever Istio need, they will keep here. So they're running a lot of container. They run a lot of services also. They keep here. Okay, so that's what they have done for us. And when you install Istio, guys, Istio give you many more CIDs. So one of the CID they give you is called gateway. What is gateway? I'll tell you in a minute. Gateway. That's what it was not there, and now it's come up. It's not nothing is created, but that is created by Istio. What gateway do I'll discuss to you. They also give you virtual services. Okay, they also give you destination rules. So there's many capability they give you. What are those they do? I'll explain you in a minute. But that's how we install. Okay. And now if you would like to implement the sidecar in the Istio, let me also share you guys one quick document from my GitHub. So if I go to my GitHub and search for Istio, I think this is the URL, and here I put almost all the main command here. Same setup. Command. Let me follow this. So this was I was talking about right now. Now in the Istio, because you know there's multiple namespaces. Namespaces. Now you can decide which namespace you want to implement Istio service mesh. Okay, let's say I want to inject in default. Then we have to tell to kubectl command, okay, that I want my default namespace, I want my Istio proxy to be injected. Okay, so this is one-time setup. Now it has been tagged in the Kubernetes namespace default, or you can take some more namespace also and say anything that is launched in this namespace, I want to inject my Istio proxy. That means if I see a pod, right, if you notice this pod I was running already, and in every pod I am running only one container. But if I delete this pod, all pods to recreate new, because mostly we eject Istio first, then we create. But if I delete, you know, they are running with deployment, they recreate automatically. Okay. And now this time you see some one interesting difference, because I injected Istio in the default namespace and the pod is launching in the default namespace. You can see there's two containers. Every pod is a two container running. So multi-core, multi-container pod. Okay. And why two? One is your main app and second is the envoy proxy or proxy of Istio they're running. For example, if I see the description of something, you can see every pod is being injected by the proxy program. And now if you see, they are running with one more container, called proxy sidecar. That is technically envoy, is a kind of project in the market. That's what they are using. Along with your main app, whatever you are running till now. They are running both together. Your main app also running review. Okay, so now this has been done. So technically everything has been now monitored. But okay, so that's how it is. It is working. Okay, now in this case, now whatever traffic is going via this guy to that guy, everything has been monitored by this sidecar or envoy proxy going to Istio some internal program. That's what is happening. Okay, but Istio also give many more things. So if you see the Istio port, they're also giving you one program called Ingress Gateway. So Ingress Gateway is again one more way to expose your services from the Istio. So if you want that your port is this one product page, and you want your port port to be connected to outside world. Okay, and that what you can use load balancer of your Kubernetes. But load balancer, if you use directly, then you won't able to track the traffic from the Istio. So Istio has given a way. They say I am giving one more my load balancer. That's called any traffic come in is called ingress gateway. So ask client, they will go via ingress gateway. So I can track the traffic coming from outside world also. If I want to track everything. Okay, so that's what guys the use of the gateway keyword or the CRD from the Istio. But I want any coming traffic coming from the client also to be monitored. Okay, so for this, there's a one program I would like to use here. So this one. And this program, guys, is a sample code. If you download the Istio software, okay, so in the sample, they given you this example, sample, sorry, book info. I just want to show you what the code is. Networking and book gateway. Okay, that's what they're doing. So what they're saying, I am going to create a gateway for you. So anyone who come to IP address, whatever given to me on this port number, I'll take the traffic, and because they're coming to Istio gateway, so we'll track this traffic of the client, and this traffic I will send to my product app because this is my front end. Okay, so I'll send to my product app running on this port number. Okay, and I'll only take the traffic who will come to this URL. So anyone who come to my IP, whatever IP given to me is ingress. I'll take this traffic, but I will route this traffic only if someone write / product page as the endpoint. Okay, and only those traffic I will send to my product page. That is nothing, is a product app. That's what they're talking about. Okay, so this is what they do, and this guy's concept is called virtual service. Virtual service. Okay, so what is virtual service? I will explain you in a minute. But they will get two things. One is virtual service, or one is gateway. So let me run this program. It's a novel program, kubectl apply. Now what they do, they create one gateway. It was not there. It was not there. Now it's been created. Okay, and they also create VS, that's called virtual service. What virtual service? I'll tell you in a minute. That means anyone who come to the IP address given to ingress gateway, they take the packet and send to virtual service. And virtual service is nothing you can think. Like I told you guys, every product has been launched behind the service. It is Kubernetes service. Okay, but the challenge in the Kubernetes service is they won't able to track what is going on, and they does not have a unequal load balance here or many things. So what Istio provide, they will have a wrapper of this service is called VS, virtual service. And because this is the wrapper by the Istio, so if anything will go via virtual service, they can track. And plus they give many more capability also. Add encryption, they will add governing, they will add compliance, they will have chaos engineering, they will add encryption with MTLS, they will add SSO, OAuth, many capability they can. Kubernetes does not support. Okay, we have L7 application load balancers, application filtering, everything we can do with VS. Okay, so we can think VS could be, if you know API gateway concept. So if you know if you guys work, that's what you can think of. Okay, you can think of. So that is a guy's whole idea. I think someone message my voice is dropping. It should not. I believe it's right. If you can again confirm. 1 minute. Okay. Believe it now. It could be. Okay. Okay. So those who know API gateway, okay, there's a protocol 3 scale from Red Hat or API gateway service from AWS cloud. So whatever they do many things. Everything we can do with VS that is not as such provided by the Kubernetes. Okay, I'm just doing very small thing. Okay, that I explained to you. Okay, now you want to see the IP of this gateway. So that has been given by Istio. Let me run here kubectl. If you see SVC, the normal service of Kubernetes, and if you see the Istio system namespace, okay, you can see one ingress gateway running that is running using again behind the scene AWS load balancer. So technically, you can think in this way: I am a client. I am connecting to the AWS ELB load balancer, so like a real load balancer. I'm heading to ELB load balancer. Okay, and this load balancer, it will connect. This load balancer, 1 minute. Okay, this load balancer is, I think the port number could be, this should work. It will work. I think it will launch in a minute. Okay, so this load balancer, guys, 1 minute. First of all, let me check. Maybe they might running on HTTPS. HTTPS or HTTP. 1 minute. Let's wait for a minute because behind this ELB is a real load balancer. Takes some time, but it will come up. Then we check. But technically, let's say I am a client. I am a client Okay, and I'll connect to uh, uh, I think there's one more thing, right? We have product page, right? My app is running at the product page. That's also, let me check very quickly. But it will come in a minute. Product page, it will come up. Okay, so let's say I'm a client and I am hitting this site. Now come up, fantastic, right? So the site, okay, but you know what the process would be? I'm a client, I hit to real ELB load balancer, okay, and when I hit this guy, then it go to Istio gate, Istio gateway, let's go ingress gateway, and they take this traffic, and now they monitor this traffic. Okay, uh, are you sending product page? Okay, if yes, then they go to virtual services. Okay, and they write, if you hitting to sell product page, that would I write here and see the description. Description, because you are heading to product page, so I will send this packet to the product page, this port number, and this product page, you know what they're talking about? They're talking about the SVC. So there's a virtual service from the Istio. From the virtual service, they will send to real service of Kubernetes to this product page on this port, and this will finally connect to a product port. Now, why are we going this way? Because your normal service does not able to track. So on the top of the service, we put one kind of wrapper that's called virtual service. And now because everything go via virtual service, now whatever your normal service does not support in the Kubernetes, we can add all the capability on the top of that. You can think this is a virtual service is one key component of Istio. This guy support hell lot of things. If you see, it's a lot of beautiful product it is. It's traffic management, security, observability, extendability, many things they support. We can do entire control by this product, request routing, fault injection, traffic shifting, circuit breaking, mirroring of the traffic, and many things we can do. Okay, that is not supported by Kubernetes, but with the help of extension of Kubernetes Istio service mesh we can support. Okay, and now because now everything is going not directly to the Kubernetes, go via all the component of Istio. Now they're collecting all the tracing information and sending to some database. Okay, and the database we can add one graphical program called Kiali. Kiali, so they can see and visualize what is going on. And to install the Kiali, we have a multiple way available for installing the Kiali, but one of the simple way of installing the Kiali. So there's a add-ons available. So in the same location, okay, in the sample folder we have all the add-ons. So do you want to install Kiali, Prometheus, Loki, Jeager, Grafana? So these are normal files. You can install directly one by one, kubectl command, or you can use Helm chart to install. There's a multiple way we can do so. But let me install everything together by running this program. They will run all the guys together. Okay. So we are installing all the tool we might use here in some time. Okay, and now if you run kubectl get pod, okay, so this is your normal page, but if you see the namespace called Istio system, you can see the log code running is an individual tool actually. Grafana, Prometheus, and many tool they are installing. Kiali also they install, and Kiali they have the service also. So they have their own graphics. So they have a service. If you want to connect to Kiali, you can change load balancer or do port forwarding, or there's one more way. Istio has given me a that command to connect. So there's a multiple way to connect. Sorry, there's multiple way we can connect, and now you will see Kiali gonna come up. It's a Kiali dashboard, and this is what you can see. And right now, because we injected into default namespace, so you can see there are 4 applications running in the default namespace. These are 4 service product default, and everything is monitored. And if you really want to see some kind of good look and feel, there's a traffic graph you can see, and here you will see a lot of data is coming. Right now there's no data because my application does not hit much from last 1 minute. Let me for last 30 minutes. I don't have enough data right now in last 30 minutes. So that's what they are not showing up. But if I ask every one of you, I'm just sharing my URL to you guys. And I suggest everyone please hit this, because when you hit this guy, your traffic of last, let's say 5 minutes, see, it's fantastic come, right? Every 10 seconds I'm refreshing on the real time, guys. It is, see, once someone hit and they go to V1 version, V1 version, right? Now my traffic is go to V2 version. Okay, or maybe V1 version one more time, because now you can see on the fly, as soon your traffic is coming up, my graph is creating. They can see multiple colors, the traffic load increasing every 10 seconds. I'm refreshing this page, or maybe I will refresh right now. Okay, so we have real traffic, and this arrow shows where the traffic is going on, and we have multiple different graph to see how what is the progress of my traffic, which side my traffic is going on. So we have a lot of different graph of my entire system. Even though we can do many things here, for example, I want to see service graph. So only the services is come up here. Okay, and in the display I go and see the traffic distribution. So I guess this is the distribution of my traffic. Okay, or let me don't refresh, post this automatically. Or I can see throughput, response time. Okay, average response time. So you can see average response time gonna come up, traffic rate, many more traffic animation to see how, see, this is the direction my traffic is going on. Okay, and maybe I want to see the version graph. If you have multiple version of one service, you can see this is the version gonna come up. Okay, so let me refresh. So they keep on showing you the version. Maybe this percentile or traffic rate. So many more things you can check and remove over here. We can record, we can replay the traffic to see the historical data, at what point in time, what was the challenge or root cause happened, why my site down for 2 minutes, that point in time. We can go back to see your traffic in, out, error, output, everything we can track. Okay, so this is very beautiful application, Kiali. multiple kind of graph we have. Again, I says 30 minutes. This is what is happening. Okay, and other thing you can further total messages and many things we can go and per namespace you can check what is happening. They also display the name also. I don't know why not displaying here. They also display the name. I now to take the mouse to see, but I don't know why. So yeah, now you can see this is the traffic. If you notice here, if you notice in the version F graph, your product page is hitting review 35%, 35%, 35% traffic is distributed equally, right? In version 1, version 2, version 3. And here they're talking about how much time they're taking and all the stuff, right? All the things they're talking about, right? So here I can see very quickly how much traffic is distributed in which version, and they're hitting equal because of the service of Kubernetes. Kubernetes support only equal distribution. But if you are looking for unequal distribution, maybe in the canary release, you can't do in Kubernetes, then you have to use a virtual service of Istio. of Istio. Okay, that's the point. And how we can do, let me show you in a minute. Okay, what you can see is a very beautiful graph. It's a real-time graph. I can run every 10 seconds. So I can see every 10 seconds what is status of my last or 2 minutes. So the last 2 minutes, they will tell you about that time of traffic and the traffic distribution. Okay, but this is possible because I injected Envoy proxy in all the ports. They're collecting data and sending via Istio to Kiali. That is the reason I can able to see it. And it is very important, guys, because almost every product platform is microservices, and we have no idea how and where the traffic is going. Without this or without tracing, it is kind of very hard or very impossible to have an entire single plane of glass of plane and to see where we are having a bottleneck. Okay, then one of the beautiful thing of the Kiali is, so for example, this is the service, the review service. Click on the review service. They will talk about the review service, this service of Kubernetes. And here they give you a button. And they can do many interesting concepts here to be implemented directly from Kiali. So Kiali gives this extra capability. Instead, you do something manually with Kubernetes Istio file. They give you some graphical way also. Let me first post this guy. So I click on the service. Okay, and click on the service. Then they will show, we can go for detail page also if you want. Okay, or let's say my plans to traffic shifting. Maybe my plan is I want to send 90% traffic to V1 version, 10% to V2. Okay, because of canary release. So I can click here. That's what we can do. Fantastic, right? Now they know we have 3 versions. I want to send 90%, 98% traffic to V1 version, 1% to V2, 0% to V3. Why? Because I have no reliability on new version. So let's see more traffic and limited traffic on the V2. Okay, V2. And after we will comfortable V2, then we'll come back here and increase the traffic. Then we can start sending traffic to V3. And slowly we go and increase the traffic to this guy. Okay, so this is a Kiali page. Okay, but behind the scene Kiali, if you see the preview, create a virtual service. And here in the virtual service, they say in V1 version, we are sending 90% traffic. V2, we are sending 4% traffic. V3, we are sending 0% traffic. So Kiali is just a graphical. They create this code for you. So you can create this code by yourself also, or you can copy paste this code and run by yourself. You can apply directly from here, whatever you want to do. Let me copy this code. Let me apply by myself. Okay, let me do something else in different way. So let's say I want to send now only 1% traffic or to this guy, some traffic to this guy, and some percent traffic, most traffic to 80% traffic to this guy. So behind the scene, they create this code, and in this code, let me apply this code over here. But virtual service is not only enough. With virtual service, there is one more concept called destination rule also we create. So what destination rule is, again one more keyword from Istio, and what they're doing, they say if anyone connect to service of Kubernetes code review, then behind service we have 3 version running, version 1, version 2, version 3. So we are defining how many version we are running, and we are giving some label to this version. Okay, and then on the top of this we write virtual services. So you see virtual service, 4% traffic will send where to this destination rule that I defined here. Okay, so this is how it works. So technically we have to normally apply for first the destination rule. Okay, so let me go to some of our document. Job, what is the folder name? Job person. Let me go to Kubernetes folder. And let me give a name dr destination rule dot YML. So this is the code we have for both. Okay, and let me apply this code manually or with the help of Argo CD. Now you can send to Argo CD, and whenever you want to change the traffic pattern or routing, you can just contact GitHub, and GitHub is the one who will control the traffic routing. And now you see there's one virtual service or VS virtual service created in the Kubernetes. Okay, and this virtual service is dedicated for the review service of default namespace of the Kubernetes, and they are getting the information from destination rule. Okay, which version has which name, and then this version say this version I'm sending that much traffic. In this case, we can see from here because this is what we apply now. Now, guys, if you hit enter my app multiple times, now you can see the real time is going on. Last 2 minutes I am checking. Okay, and now I suggest everyone please hit. Now you will see, okay, my safety 70% traffic, whatever I write, will go to V3. Some percent go here, and V1 they will see very less percentage. Okay, so if you see in some time, because after keep on running multiple times, you can see even right now also you can see this 70% traffic go here, almost 20% traffic go here, and less than 10% traffic will go here, and slowly as more requests come up, we can see this difference. So we can do it very now simply because of virtual service industrial rule of Istio. Okay, so this is a kind of canary release we are doing very easily. Same way, if you want to go for different concept, A/B testing or blue green deployment, those things also we can do from here very easily, because doing blue green deployment, if you know, so we have one site is running in production, so blue, okay, and there's new version gonna come up, so we have one more staging area that has same kind of setup. We launch a new version there, and completely we shift the URL. Blue green deployment. Okay, so doing this thing uh, from the Kubernetes, we can do everything in the Kubernetes by some tricks, but it will be very challenging. But if you want to do blue green deployment or A/B testing with Istio, that is very straightforward and very logical, and maturely they have created this product. And if you notice, guys, here now see only 1%, 2% of it is given V2 and V3, 50%, 80% traffic. So it's a very beautiful product to be used, and many things. If you guys know, whenever you launch this product, this version might goes down, so we can inject the fault, we can do fault tolerance, and many things we can implement from here. Fault injection and many things also. Okay, so that's a beautiful part of Kiali is a dashboard. Okay, but behind the scene, we use this guy. Behind the scene, we use Istio keywords like service, virtual services, and the destination rule. And if you see, guys, Kiali itself is a big tool we use in a lot of organization. Kiali. Kubernetes. So this is a official page of the Kiali. Okay, and you can see there's a lot of company for a lot of use cases. Tracing is one of the things I was talking about. Had been used by a lot of company. You can see maybe some client page, the list of client who is using the Kiali. Okay, so this is the whole idea. I suggest practice till here. Okay, step-by-step command. I will post you, or I'll share one more link where you can get this command. So I'll share this link. Where it is? Yeah, this link. So you guys also go for this link to step-by-step command for doing so. Okay, so that's also you can use if you want to use it. So take some time, guys, and do this practice, and then we have some more topic to be yet to discuss. I'll discuss very quickly in some 15-20 minutes. By the meantime, practice this part, or otherwise if you have any query, you guys can ask. So guys, after this, there's a very more important concept to be discussed, very important. So so uh, uh, in 15 minutes we will do this discussion. By the meantime, take your time to grasp and digest this concept, and then 15 minutes we will have some more very interesting concept that you should know for this two jobs for Sinji and the Accenture. Those who can do this practical definitely do it. Otherwise, at least try to grasp and try to digest what we discussed till now. Okay, so we will, guys, connect you in 15 minutes to have some very important discussion. Okay. the next part. So the last concept was we was talking about Kiali for the tracing purpose. That is what we have done. And now what I am going to do right now. So I told you monitoring is a big world altogether. What you want to monitor, that's make more logical sense. For example, if you want to monitor metrics, for example, so what we can do, okay, we can use some of the metrics tool. Maybe you can use AWS Cloud Watch metrics that has also have an agent, okay, agent to be inject in somewhere to collect the data. Or if you want to have some general tool, we can have Prometheus, okay, and many more tool you can find in the market for this. Okay, so Prometheus is one tool we can use. It is not only for Kubernetes, it is a general tool we can use in many other area also. There's one thing, but there's some tool is very specific. For example, Kiali is only for Istio, and Istio is only mostly for Kubernetes or Kubernetes kind of tool. But Prometheus is one tool, ELK or Splunk, Grafana is these are tools they can use in many different environment and areas also, right? But yeah, mostly in the world of Kubernetes, you see Prometheus, Grafana to be used a lot with for the perspective of metrics monitoring. So what I'm doing right now, okay, in my case, I already have Prometheus installed from some of the add-ons. That is nothing is a Prometheus YAML file, okay, and you want to launch the Prometheus. They also have their own dashboard. Okay, so that's what I would like to do right now. So I'll use Istio serial command is one of the way. Otherwise, this is a one kind of shortcut I can say. Otherwise, we have Prometheus service available. You can use the service to connect to the dashboard of the Prometheus. Okay, but right now what I am doing, I'm just using this shortcut command from Istio to get the Prometheus dashboard. So Prometheus has one agent running inside the Kubernetes. Yes, Raghu, the Kiali is any Kubernetes system. Kiali is compatible. So OpenShift is a Kubernetes behind the scene. So Kiali would be run with OpenShift also. So there's a Prometheus dashboard. So Prometheus is collecting the information, storing in Prometheus database, and to query this this what I say, the database, we have promql command that you can run from here. And for everything, they have a metrics name. For example, you want to know something about CPU, you can type here, then all the metrics name gonna come up. For example, if you want to see machine CPU code here, okay, if you execute, then they will tell you that, because guys, I have two worker node, the two result gonna come up. Okay, and they're talking about one of the worker node in my this cluster, okay, having the instance this IP address. This guy having using M5 extra large in AWS cloud, and that has some CPU to be used. So that's what you can see here very quickly. So you want to see how many machines has been attached to. In my case, it's Kubernetes. So they say there's two machines, and we are using M5 extra large as a machine. Okay, or we can further filter also. For example, if I want to know only about only about, for example, I'm looking for only the machine who have this architecture, or only the machine who have this instance type. Okay, so what I can do, I can copy these guys, and there's a way to filter. You can use curly braces and give this key and value pair and hit enter. So out of all the outputs, okay, any machine that has tag with this key and value, they will come up. Again, we have two because we both have the same. Or I can say only the machine who have instance name this one. So let me copy this, and I can use comma. Is like an AND operation here. Execute, then only one gonna come up. One gonna come up. So this is how we can filter. So this is called promql command. Okay, or we can do something else. Let's say I write pod, so they can see a lot of thing about the pod or kubelet. Maybe we have some issue in kubelet pod, so I can click on kubelet pod, and you can see there's two kubelet running. Why? Because I told you kubelet is agent running in the worker node. So I can see in the both the worker node kubelet is running, and all the information whatever attached to this kubelet metrics, these are the metrics name, will be come over here. Or maybe I want to check something about memory, mem. Okay, so I want to check about the container memory swap. So almost every possible metrics, whatever they give you by default, we can also create something custom. That's a different point, but they give you lot many information about whatever you would like to find. Okay. Plus, I also have some pre-created query here, just to quick check if you want to check. For example, I want to see about total request coming in the Istio. Okay, so I can go to Prometheus and write this also one of the metrics. Click here. So till now in my Istio, we are having 30 requests, and guys, Prometheus also maintain the time also when this request happened. So that's called time series database, and because we have a time, we can very quickly create the graph, okay, on respective things, whatever you want to, whatever you query, accordingly they create the graph. Okay, but mostly we use Prometheus for querying the thing. Or we can further filter the way I show to you. So I can say the total request coming to product page. So product page is a service. So I can write the name of the service that differentiate the product app. Enter. So out of 30, 15 requests, Istio request coming to the product page service of the Kubernetes. Okay. Or plus they have Prometheus also have a lot of internal functions. So I want to see the rate of product services past 5 minutes. So rate is a function. Okay, and we can give the filter here. What I want to filter, I am looking for all service with product page with a response time 200, not 400. I want to see the rate of the product page and exist in the rate of 5 minutes. Okay, so mostly whatever we can do in the world of metrics, we can do here. This output gonna come up. So with aggregate of 5 minutes, we are filtering, seeing the rate on the product page. This is my destination service with the response code 200 or 404 or 501, depend what you want to retrieve the information. And then if you want to create a graph, that graph will be created for this rate. Okay. So like this, there's a lot of functionality available and a lot of metrics available based upon where you install the Prometheus. That much metrics you have here. But this information, guys, what I am searching in the Prometheus, because have the own database called Prometheus database. They're retrieving from there from this query, but this information I would like to present in a very some kind of sophisticated visuals and the graph. So for this, instead we use the graph from Prometheus. There is a limited options. There's nothing much we can do here. So this information we can send to Grafana. Grafana, and Grafana will convert this information in some kind of very beautiful, sophisticated graph. So we also have Grafana installed in my case. So it's again is an individual tool. So I can get the dashboard of the Grafana. Okay, Grafana that look like this. Okay, and here in the Grafana, we can connect this Grafana to multiple databases called data source. So if you see in the left side, there's a the connections here. So we can create a Grafana with many different databases to retrieve the information. One of the things, maybe mostly we use Prometheus. But we can connect with many different databases. Okay, it become data source. In my case, the way I installed from Grafana, we already have Prometheus connected. That's running in my Kubernetes. There's a URL of the Kubernetes because they're running inside the Kubernetes. So my Grafana is already connected to Prometheus to collect the data. And there's a button called Explore here. If you click the Explore, now whatever you have done in the Prometheus page, this query, same query you can write here, but they give you better way. Okay, I can select my metrics name from here. Okay, for example, my metrics name could be Istio. All the metrics name gonna come up, whatever you are looking for. Or maybe let's say memory use. Okay, container memory cache and whatever you look. So all the metrics they will retrieve by the Grafana. Let's say envoy memory allocated. Okay, so see this metrics name. Then I can filter. Okay, I want to see with the some instance a key with some value. So the same query, guys. Here, same query will be created directly from the Grafana. Over here, we can click on run query and they give you the output. And plus at the same time, they also create a graph based upon the time series graph they created. We can just change the time, last 5 minutes, and so on, all the customization we can do. Or if you think this is the graph you always want, okay, so you can create a panel and add it to the dashboard. So you can create a dashboard and add to the panel. Okay, and because Kubernetes, Istio, Grafana Prometheus we use a lot, so we have a lot of pre-created dashboards available in the market. You can download from somewhere. And even though in this case, if you go to dashboard, so we have some pre-set up dashboards available. This is called Istio dashboard. So for example, I can see the Istio workload dashboard. So they give you pre-created dashboard over here. So I can see in last 3 hours, this is the traffic happen in from the Prometheus, and Prometheus capturing from Istio or Kubernetes. Okay, Kubernetes, and which namespace. So there's a namespace gonna come up, and workload is my all the ports. So I want to see the data product app, and the destination could be somewhere they want to go, or all the workload in which namespace you can search. And if you notice here, they are showing you this graph, right? So at this point in time, there's some huge request because maybe I ask you that point in time to click my portal. You can say there's one spike here on the request duration, and many more traffic, whatever they have, they collected as a real traffic. That's what, guys, you have connected today with my app of the book info. Okay, or maybe we can search for last 5 minutes, and here I can see auto refresh. So this is a live graph they will show you. So any changes, if you now guys hit my product page right now, you can see the graph will be populated automatically because I'm searching for the product page. Here, this is coming, guys. Someone hit my site. So this was the live traffic is coming up at this point in time. Similarly, we have many more. pre-created dashboard. So maybe I want to see the service dashboard. Okay, so same thing, last 5 minutes, I want to refresh automatic. Okay, from the product page, for example, again, and almost everything we can find a filter. So again, there is a live graph is being created, and this graph is nothing. This is a one panel, and this panel is been created with the way I show you. If I show you the way I explained to you. So, for example, this is a client success rate of 500 response. So, if you open this, is the same panel. Behind the scene, they are running a Prometheus query. The way I explained, this is the query they are running. So, we're using Istio request total. We're filtering something, whatever they have, 500 error code. We are seeing the rate of 5 minutes. Then we are sum and do many something here, whatever they're doing. So it's a pure Prometheus query. I'm putting on the Grafana and asking the Grafana to store as a panel. And this panel I'm putting into my dashboard. That's what is visible here. So you can create a multiple custom dashboard. Okay, in this way. Okay, so guys, this is a quick information about the Prometheus and the Grafana at this point in time. Okay. Otherwise, there will be a lot of functions available in the Prometheus. If you search for Prometheus, from QL cheat sheet, okay, and you can go for the document of prom QL. So there are a lot of functions available. Okay, so these are the example: 5 minute filtering, increase, sum, count, like a normal SQL. So whatever mostly the function we use in what I say for analytic purpose. So those function, aggregation function, group by function, all the things you can derivatives, deltas, and you can find here. So again, itself a big tool to be discussed. But my point is the main core part of the Prometheus is they are monitoring your disk uses or memory or the CPU or the file system, the network, because they're collecting those information. So on those information, we can write some query and analyze whatever I want to analyze or troubleshoot. Okay, so that is a one key part. Okay, so guys, these are the some few part. I would like to tell you one more thing. If you just talk about Kubernetes, just these are the, again one of the some of extension or the program that we use with the Kubernetes that you should know. But there's some more concept of Kubernetes that is could we ask the interview in both the companies. So that would be the last topic I would like to discuss for this program. Okay, and this topic is again very important. But one more thing I want to add. Okay, we'll trying our best to help everyone. Okay, in the placement of Sinji and Accenture. Obviously, they have some number. Number is big, but you guys are almost 200 around now. So not everyone will get it, but this knowledge, what I am giving to you, it help you in other job also that we keep on coming in the future. Okay, that's what I want. Just to that is the reason I keep on telling this point because this knowledge and then in time we invested won't be go unwanted on the trash. It will be helpful in some in other way. Okay, so this is Grafana. Now one more guys quick information I would like to tell you is very important concept. The concept is if you talk about guys, this is very important concept again repeating. So when you talk about multi-tier app, okay, when it's a multi-tier app deployment. So typically what we have one front end, okay, then we have some back end, or let me make it a little bit more simple. Let's say we have one front end with the back end, okay, let's say PHP application, for example, and then this application is storing a data permanent in the database. So what happens whenever any client hit to your front end, let's say there's a PHP application, one of the good example could be the WordPress. Okay, the WordPress is only containing the code, or they are only computing the code of PHP. So whatever sorry, whatever you read or store, that PHP will go and connect to the database. Mostly they use MySQL, for example, behind the scene. And both the this is an individual program, in our world. We can run this guy as a pod, this guy as a pod. We can run. So it's a multi pod, not multi-content, multi-pod setup to implement multi-tier application. Whether it's tier 1, tier 2, tier 3, so multi-tier application we have mostly. Okay, but in this case, okay, there's one important point to understand, guys. It's a very important point, okay, in the multi-tier app. Okay, the point is if you're talking about this this layer, okay, mostly known as business layer, or let me use a simple term, front end. Okay, so let's say there's a front end is running here as a pod. Okay, and let's say every front end can able to accommodate some number of requests from the customer. So more customer gonna come up, we know we can very quickly launch multiple pod as a replica, and obviously we run behind load balancer called service. Okay, so we will load balance. Now you can, it's your choice. You can use Kubernetes service or you can use virtual service of Istio. That will be your choice. Okay, so we have a multiple front end is running by same code, that is let's say PHP code. So whenever any client gonna come up, client is hitting to this service somehow, and they're doing the load balancing. Okay, now understand one thing, in this app when I talk about is a pod running with a language, let's say Python, Flask, or PHP, whatever the language would be. Language, guys, only contain the code. Okay, only contain the code, and whenever anyone hit, they only run the code. Means code is the one who compute, and mostly, okay, this front end or maybe business layer, we only contain the code and we only operate and run and compute the code. We don't deal with the data. We don't keep the data here. And if this application wants some data to be read, to be to be update, it's called CURD operation. We normally store it somewhere else, and mostly this is the database. So those information, maybe username, password, your post, your blogs, your product, your cart, we store in the database, MongoDB, MySQL, whatever would be, let's say MySQL. We store here. Okay, and what we do, so there's a database running, this also, let's say, pod. Okay, and this pod also we don't connect directly, we again have their own personal service for this pod. So technically the process would be, client send the request to service, it will go to, let's say, this pod of PHP front end, and this guy connect to this service, the service connect to the MySQL database where you're keeping your data permanent and the persistent in the database. And they reply with the data what is asking and updating, and they provide to PHP, and PHP will process something and give back to the client. This is what we happen, right? Always. Okay. Now, in this case, there's a two app is running. One is a PHP port or app, and one is MySQL port or app. Okay, but where is my data? In the MySQL. Where we are doing CURD operation means create, read, update, and delete in MySQL. PHP has nothing to access, manage the data. Whatever is be changing, that is called state. Okay, for example, I have posting some post in the Facebook. So where I hit to Facebook is less of a front end or my back end business layer. Okay, so here this may be some index.php page here, and they have nothing to deal with the data in terms of data storage. But we can see the data somewhere here, because we're pulling this data. This front and backend is pulling data from the database, whatever Facebook is using behind the scene. It means if I do some change here, delete anything, did a new post, it will be update in the database. Means whatever you do with the data, that's called state. State has been managed by mostly the database: MongoDB, Redis, memcached, Cassandra, PostgreSQL, SQLite, depend whatever database you use. That is called state. Who is maintaining the state is called stateful. So these applications are the stateful application because they're maintaining the state at this point in time. What is your current state of your data? And what are kind of the data? For example, my current state of my last post in the Facebook, there's a last post, whatever we post in this portal. That is my last post. That's my last state. Who is maintaining? My database is maintaining. It is not maintained by PHP. Only thing is when I hit to the PHP have no idea. They go to backend, fetch the information, give back to me. So PHP is not maintaining any state. So I can say this is stateless. So this pod or this application is stateless. So mostly the pod or the app where you're running a program who only compute the things are come under the category of stateless app. In this case, stateless pod. And the one who is maintaining the state are stateful. That is mostly they date and delete the data, store data, last update. That is called a stateful app. Okay, now I am discussing this point to you. Okay, because it is very common that if we have a load increase, so we launch multiple pod as a copy. Multiple pod as a copy. But here in this all the pod, we are using the same code of the app. You're not storing same data. It is just a code. Let's say print hello. So everyone is running print hello. Now my client go to first one or second one, third one. Everyone has same code. They are on the same code. So it does not matter where the client goes. We don't have to maintain the state. So we have no challenge wherever my client will be routed by the load balancer. So in this case, to launching this pod, we can go and use a deployment. Okay, for creating the replicas. That's what we use till now. Scale deployment, Kubernetes scale command to do this. So deployment is used for creating the replicas. If you are running an image or pod with only containing the stateless applications, mostly the program or business logics, front end or back end program. But okay, if you have a more load gonna come up, and if you want to create replica of your databases, same database I want to replicate IP1, IP2, IP3, same database. How can replicate? If you do the same thing with deployment, then you face a lot of issues. Okay, and what issue you will face? Okay, because there's a chances. My first time, one of my client SM is me, Vimal. is heading to service sending to this PHP code, this PHP code is going to service sending to this first MySQL port. And here Vimal come up and they do and launch a post in, let's say, the Facebook. First post they update here. So this is been updated MySQL in the MySQL database in their local store. Because this data, right? They store somewhere in the local hard disk storage. So in this case, there's a possibility that next time when they will come up, they hit to next port, they will go to this service. This time the service might connect Vimal to this MySQL database, and this they have their own personal storage. Storage, okay, but here this storage does not have the data what you have put in first port. Here this may be a different data. Means it is something like this. When I refresh this page, next time my data not visible. If I 2 or 3 times, when I hit the same port again of MySQL, I can see the data. This does not make good sense, right? Okay. So wherever you store data, first of all, we never want to use. Okay, I want to run my database program here, but I does not want to use local storage to be attached. So what we do, one of the things what we do is we create a storage that's called volume in some centralized location. And same volume we connect here, same volume we connect here, same volume or storage or persistent volume we connect here. This connects called mount. Now it is your choice. You want to mount using NFS or iSCSI, and there's many more protocol available. For this you can do. And this volume is nothing is called hard disk or the storage, and in this the volume we can store our data permanent. That's called PV, persistent volume. But whenever you want this volume, let's say you want a volume of 10 GB in size, 10 GB in size, so wherever you want to use this volume, connect to these port. Okay, what you have to do, you have to first claim this volume, ask this volume to be used. This is called PVC, persistent volume claim. So somehow you'll claim this volume that I need 10 GB to someone, and they will provide this 10 GB to you, then you can use. Now, how you can claim? Maybe you can claim manually. Some of a storage team can give to you, or nowadays we claim my storage. This is called dynamic provisioning with a concept called storage class. So there's a storage class concept. So these are the guys keywords here in the Kubernetes world. Kubernetes get PV. There's a real like hard disk. We have PVC. These are the one who give me the hard disk by claiming. But this PVC is go and contact to storage class. Okay, storage class. And storage class is the one who actually get the store from somewhere. So storage class is more like a driver or running the driver behind the scene. And you can ask this guy, give me the store from NFS volume, give me the from AWS cloud, from EFS surveys, give me the from let's say HP Hitachi, give me the storage from some NetApp. So you can get the volume for multiple way. For example, we already have one storage class because I'm using EKS cluster. So they have connected with the driver called EBS. So when a PVC asks for 10 GB, they go to storage class, they contact them EBS service, AWS cloud. They get the 10 GB from EBS, and this 10 GB we give to PV. And this PV I can add to one of my port. So it is work like this. Okay. So I think this part you might know already. But those who by chance does not know this concept, I'm not showing the demo because it takes a lot of time to set up this right now. But if you guys does not know, I explain this some concepts to you. But you might know this concept. But this setup I've seen a lot of guys use, but that is very very wrong. So if you know this setup in this use case, then it is not at all recommend to use this setup. Use this setup. Okay. Why not to use? Let me explain this concept to you. Okay, I'm not saying PV, PVC, and SC is issue. In this example, especially in MySQL or databases, this is not at all recommend. Why? Let me again draw this diagram. Let's say there's a database running, and we have multiple copy of database program we are running. Program 1, program 2, program 3. These are the different port, replica of the port of the database. Okay, and if you're getting the storage centrally and attached to everyone, that's called mount or the bind. Okay, that means if any client come up, either they go here, they can see the same data. Either they go here, they can see the same data. Or if they go here, they can see the same data, because none of the guy has a local storage. Everyone is getting the storage from central because of the PV, persistent volume. Let's look like this should work. It will work. It will work. But the challenge is, okay, if you have two requests come together in a kind of concurrent and in the parallel, okay, client 1 request to client 2 request, and maybe one of my requests go to one port of the database, second will go to second port of the database, and both the requests we are doing operation on same data, and data is the storage, right? Same data, same location. Okay, so someone is asking that, hey, I would like to withdraw some amount. Let's say this is data related to currency or amount, money. Okay, so someone say, I want to withdraw the amount. Let's say I have the total amount in my account is 10 INR. Okay, and both the requests come up here from the same other client. They want to withdraw the 10 rupees INR. Okay, and if both the requests go to the same hard disk, and maybe at same point in time both the requests gonna come up, so they can see, both those guys see the same amount, so they can withdraw. So technically I have total 10 rupees, but they withdraw 10 10 two times, so that is not at all very much logical, but it should possible. And this is called race conditions. Okay, race condition, and that also will impact in the concept of consistency, so that will impact the consistency of the databases. Okay, so in the database world, guys, whenever we use replica, we don't use this concept. We can use, but whenever this race condition gonna come up, you will see you have data to be inconsistent. So inconsistency issue will be always come up. Okay, so what we mostly do, okay, in the world of database, okay, so whenever you create any first port of the database, there's a database program, okay, and whenever you think the huge load gonna come up, you can get one more copy, but this copy, that's the first copy, second copy, this copy we can use for both the purpose, read and writable, but this copy we only use for read only purpose. Okay, and this concept is in the world of database called read replica. We always use your read replica concept to safeguard from the performance and plus from the consistency issue. So you can get many copy, okay, and that's for read replicas. Okay, and now there's no challenge. We have one central database that come from PV. PV will take the from PVC volume claim. They will take from SC. SC will go and contact to EBA store of AWS cloud and some other store, does not matter. Now this PV is one central. We can connect to everyone here. Everyone here. Okay. Now any request gonna come up. If the request come for read, they can read from anywhere. Does not matter, because they can see the same data from same central location. But any request that is coming for rewritable edit, that will always go to the first port. First port. Okay. So this is what we want. Now, the challenge is, if you want this concept, if you want this concept, that the first port is always to be read writable, or most known as a master, or read-writable database. Okay, and next will be read only. Next will be read only. If you scale, and if you scale in means you want to delete, then I never want my this port to be delete. When I want to delete to scale down, then we want to read one of the read replica. Okay, this won't be possible, guys, with the deployment, because when you launch the deployment, when you create a deployment, when you create a replicas with deployment keyword, okay, they never maintain the sequence. So they can launch multiple port. If I say 3, when I ask them to delete, they can delete anything in between. When you want to delete, this called scale in or scale out. Okay, but in this example of databases, here the sequence matter. Whichever I want to launch first, it should be rewritable. What I launch second, third, fourth, it will be read replica. And when I want to delete something, I want this guy to be deleted, neither the main one or the master one. In anyone, in MongoDB, there's got clusters or whatever you say, guys. Here, we have this. Okay, and that is the reason, guys, in the world of stateful stateless app, we can create a replica with the help of deployment, because their sequence does not matter. Wherever they go, they only run the code. But in the world of databases, they're stateful because they're maintaining the data. Okay, we can take the volume from PV. That's code. They are the one who give the storage. But these replica we will never launch from deployment. Here we use a keyword called stateful set. That's what we use. So this is one of the great example. Okay, why we need to launch pod with stateful, neither from daemon set, neither for deployment, or neither for the static pod, only the pod. Okay, because stateful has a capability, okay, to have multiple pod as a replica, but they also have a capability to understand the sequence. Their first pod is a master pod, and next pod what they launch is the slave pod or the read replica pod of the cluster. Third pod is the same read replica, and when you want to scale in, means you want to delete something, then they'll read on the read replica pod, not the main one. So stateful has this capability to do, okay, from the Kubernetes perspective. But okay, only stateful is not enough. We have to write lot of, if you guys know MySQL, in MySQL we have to create a cluster. So you write a lot of clustering command to join the read replica and into the cluster. So those things also is right in the code of your of your MySQL or MongoDB maybe. So if we quickly search Kubernetes MySQL, just example I'm talking about, MySQL state full kind of example. So you guys might see some examples of MySQL or any other databases also. So this is an example of MySQL. So instead of deployment, I use stateful set. I'm getting 3 replica. Okay, and here I am going to create my first container for MySQL image. And here I have run all the MySQL command. This command has no relation with Kubernetes. It's a pure, those who know MySQL. So there's a MySQL configuration file. And here I'm just putting my cluster ID. Okay, this is what we are doing. And the second pod that we are going to launch, it could be my backup pod in this case, I think, or maybe a read replica pod, depending on whatever they're doing. Okay, or maybe you can find some more example, depending upon what you're setting a backup port or the replica port, we can do here. Okay, so this is a configuration file, config map, but in the service, a load balancer. Maybe they have example of stateful. Yeah, they have by chance. So using MySQL, and we are using first port. This is a master, and again, this is the same example. I think they are getting here, but you can see read replica also some example of in some of the site. But my point is, this is the core concept of stateful, because it's very high chance. This is very commonly asked question in the interview, different deployment and stateful set. Okay, so deployment for the app code, that's called stateless apps, and for stateful, the who's maintaining the state mostly in the databases. Okay, and where the consistency is critical part. Okay, then we use state full set for for maintaining the consistency, means the way I explained to you. So this is again one example. In that they have one application only, but I think you understood the concept what I am talking about. Okay, this is one point. This is the guy's quick example. The demo would be big for this, so I'm not showing this, but this information is enough to talk on the interview part. And one more last thing, very quick thing is, okay, mostly whenever you use any images, guys, like if you go to Docker Hub, okay, and if you want to use a MySQL image, for example, MySQL image, okay, and many more images. So these images say, whoever created this image, then say if you want to use this image, you have to provide some information. MySQL needs some database created, username created, password created, and you pass by some environmental variable. Like Docker, we can pass this variable. So some of the environmental variable you have to pass. Okay. If you don't pass the environment variable with the root password of the database, it will fail. Okay. So in the configuration file of YAML, the deployment file or the stateful, you have to pass the environmental variable with the password. But if you pass the environmental variable in your code, then anyone who have the access of your code or YAML file, for example, this is a YAML file we might use, for example. So while launching the MySQL, you have to pass some environmental variable here. Anyone can see the password of database. That's very, very sensitive. Okay, so that is the reason we don't store the password directly or any credential directly into our config file. Instead, what we do in the world of Kubernetes, we have one more keyword called secret. secret like a box. Okay, and this box we create we create, and in this box we keep our login and password. Login and password. Okay, and in the Kubernetes file we give the reference. Rather we store the password here, I can say go to this box, and whenever you need the password to give to MySQL, you can keep the password from there. Okay, that's what we can see. Mostly if you see any of the MySQL code or any of the database code, this is what mostly you will see in most of the configuration. So whenever I would like to use MySQL port, this may be the example, maybe some example. Let me show you very quickly. You will see. Remember this one. So we are using MySQL image or container. It will fail. So we have to pass the environmental variable. With this is the name of the environmental variable, but I show you from here. And the password you can give whatever you want to give. Instead, I can give the password here. If I give the password here, so it's visible to everyone who have the code, or you can run the Kubernetes describe command on the pod. Instead, what we can do, we can create a secret, and I can see the secret name here. And I can say in the secret, you has a key called password. Go and get the password from there. It's a key variable that I create in this box. This is what So whenever in the YML file, if you want to put any sensitive data, don't put. We will put in the secret, and from there we get. Okay. I think this, guys, maybe you might know this part already, but I want to tell you something else. Something else here. Okay, we feel, those who know Kubernetes or maybe OpenShift, they feel if I don't put anything in my code, that is not I'm putting, so this is not password, this is just a variable name. So we feel we are secure because we are storing everything in the secret. A secret will make the thing secret, but that is not the fact, guys. Okay, why? Because whatever you create, whatever you create, stateful set, secret, PVC, we always create with a code. Okay, so very quickly I'm going to show you one quick demo what I'm trying to tell you. Okay, so let's say I want to create a secret. There's a command called secret. Okay, I'm going to store some generic information in the secret part here. Okay, and let me see the help. I can take this one quick pre-example from here. So let's say I am going to use let's this example. Okay, so past LSA, my keys, my pass, and my password is Red Hat. So we have created one secret. Okay, secret with this name, my secret. And this is the kind of box. In this box, we store this variable. So if we describe, we have this variable, my pass, and we store our password. And then I can tell my MySQL go to the secret called my secret. There's my secret name, and there's a variable called my pass, and go and get the password. So thing will work. And why we're doing so? Because we think this is how we can secure the thing, but no, it is not the secure thing. Because okay, nowadays we use a concept called GitOps. We are putting everything as a code in GitHub. Secret is also one thing we store in GitHub. It means when I try to convert this guy into the code, this is what the code created. And if you notice, guys, this is the code we will put in my GitHub while I share to my other team. And now if you see here, this is my secret, this is my variable name, and my password is Red Hat, but this does not store password in this format. So it look like we are secure, but it is not again secure, because this password Red Hat is converted into base 64. It's encode. And anyone who knows this concept, we can very easily decode this code. There's a lot of commands available in the market. Let's base 64. I can give this password here, control D. Sorry, give this password here, control D. Sorry, base 64 I have a D, sorry, decode. So I'm decoding this password. See here, there's those comma, right? We can easily decode one click. So storing password into secret, it is not giving you a security. So the right answer would be, we create a deployment to launch the pod or something stateful set to launch the pod. In the pod, we will never put the secret. We'll fetch the secret from secret, or the password from the secret. But in the secret, we are also again not putting the password here. Okay, here we can give one more reference because this code is going to upload in GitHub. Anyone can accidentally upload and git push, and the password break is very, very sensitive. Okay, so this password we store in some centralized tool who is specially designed for maintaining the secret. And one of the great tool in the market where I can link my secret to that particular program is HashiCorp Vault. So this HashiCorp Vault we can use that is specially designed to maintaining the secret. So it's like centralized tool. So we are not keeping anything in the Kubernetes as such. Okay, so this is one of the program we can use, or we can use AWS Cloud. Why not? So in AWS Cloud also, if you know, where's my cloud? So if you go to AWS Cloud, I don't have login right now. Okay, you go to AWS Cloud, and if you know in the AWS Cloud, we have a system secret manager service, AWS secret manager service we can use, okay, to store my secret. So my secret will be stored in AWS service cloud secret manager, and my Kubernetes will only give the reference here. Okay, so technically none of my configuration file or YML file of the Kubernetes have a secret. This is the most sensitive thing, obviously. So whenever they want, they will pull the secret from these services. But there's one more one more mostly common way we use in the world of Kubernetes. Okay, so if you search for concept called Kubernetes sealed secret concept, this is what we can use. Sealed secret. Okay, so same concept. So sealed secret is one kind of specialized program available in the world of Kubernetes. So it's a kind of common central area where we're maintaining the keys and secrets here. Okay, and this guy is giving to secret, and secret is the one who is using in the port. But the point is, okay, whenever you want to store any sensitive data, we never store here. We always take from the secret, because this is the keyword is available to us to give the reference. But in secret also we don't put it, because this file is shareable. Anyone can get it, because we put in the GitHub for doing some automation or collab with the team. So here also we give a reference of my sealed secret program or secret manager or HashiCorp Vault. Many more programs like this available in the market for this purpose. So this is how we should do and we have to do. Okay, that's very important. So these are a few very important. Wait, guys, can you hold for a second? And so these are few important, very important concepts to be add to know, and there's a higher chance to discuss our field a sealed secret in this concept in the interview, and the higher chance to discuss our stateless, stateful dev and set differences that I explained to you. And this is one thing. Otherwise, there are many topics. I think today, I don't know, it's a almost unlimited topic and tool I touch, and lot of demos I show to you. Okay, but now, guys, there will be many more keyword in the world of Kubernetes. So, but these are the very important keywords, and the resources I explained to you. Some extra CRDs that could be very important. I explained to you. We have a quick quiz, guys. I think my team, Sayed or Dilip, can you please confirm me? Are you ready? Okay. Guys, the next process from my side is there will be some few resources I will provide you in Hash13, free from our side. I told you, for example, multi-stage build, and some of them other topic could be. So I suggest before you go for the interview in the Sinji and the Accenture, quickly go and but before this, just go and complete this topic. Plus, what we have done is these 2 days. I will try, guys, within 1 or 2 days. My team will create one reference document of step by step of this command and the concepts. Will provide to you, so it could be a quick recap before you go for the interview. Okay, and maybe Preeti might tell you in some time, but maybe mostly maybe today or maybe tomorrow. From our side, we will give you the shortlist what and to whom we are sending. From our side, what to whom we have shortlisted for Sinji and the Accenture. Okay, that's what we can do. I highly suggest, guys, the Preeti has given the form right now. I think just before my class start. This is a very critical form because we'll try our best to as much as placed. But anyone who is not yet shortlisted from first round or from our side or maybe these company side. Okay, so based on your current challenges, guys, or based on the current requirement, everyone has a different requirement, different hike or many different challenges. It's a one-to-one case basis. So we have some data we can map for the future company. Okay, map for the future company. So wherever we feel there's some delta part to be help you in multiple different, depending on what you ask in the form, so we can help and map properly for the future companies also. That's what we will help you. So fill the form what we have given to is very, very critical. So it will save our time also and quickly take a decision for the future companies. Okay. But anyone who is looking for entire DevOps training, we are starting soon the entire DevOps training. That's also you guys can join, or only the Kubernetes training also you can join. And one more last thing I would add here, guys. What I understand from last 2 days, based upon your query, based upon the query what you put initially when you fill the form for this program, and what Preeti is talking about by having some one-to-one quick discussion. There will be a huge challenge in the terms of mapping and the profiling and showcasing. Okay, everyone has a different kind of experience, kind of expectations, kind of custom requirement. So maybe we'll try. I don't know how we are thinking something, guys, to do one-to-one profiling. Okay, so everyone individual need can be solved and link and map somehow to XYZ future companies. Okay, so that's also we're doing. So individual profiling and mapping is, I think, is very critical thing to work because something can't be generalized right now. This training we kind of generalize, I can say, based on Sinji and Accenture, but there will be more customization we need per individual basis. Let's see how we as a Linux world can accommodate and provide those many resources to, so a one-to-one profiling and mapping to your current need and requirement and your growth. We can do so. So let's have quick discussion with other team members, and we'll try our best so that almost everyone is till now what we have here, we can help to future upcoming companies also. So that's what I would like to say. So from my side, very very quick recap. So you should know these some important keyword of the Kubernetes that was discussed about PVC storage classes. We should know Argo CD. We have some very quick discussion CI/CD pipeline, where to use Jenkins, where to use Argo CD, what to use of service Istio mesh, what Kubernetes can't do, what Istio mesh can do for you, microservice setup, monitoring, tracing, different kind of deployment strategies. Some of the things I show you the demo, and Prometheus, Grafana, and many other tools we discuss, and stateful set or sealed secret, not to store passwords, credentials in your YAML file. Rather, we have some stored in some vault. Vault is just concept. One of the vault could be sealed secret, is just a program name. or HashiCorp Vault and many, or AWS Secret Manager. So these are the guys, some very quick information we have discussed. Okay, so that's all from my side. If you have any one-to-one discussion with me, we'll do. But I would like to, Preeti, it's over to you if you have anything to be discussed further.
Thank you so much.